Hello and welcome to the live broadcast of Rocket Lab's 6th Electron mission, STP-27RD, a dedicated mission for the U.S. Air Force's Space Test Program. We are coming to you live from Launch Complex 1 on New Zealand's Mahia Peninsula and from Mission Control right here in Auckland. We're approximately 15 minutes away from target liftoff. My name is Max Muncy, and I'm part of the launch operations team here at Rocket Lab, and we're thrilled to have you join us for our second launch of 2019. We just received confirmation from the launch director that we are go for launch. We have approximately 14 minutes until T0. The weather is looking green and Electron is ready for flight. The vehicle is fully fueled in both stages as we started filling the liquid oxygen tanks at around T-minus 2 hours and 30 minutes. Those white stripes you see around Electron indicate where the chilled fuel is icing up over the vehicle's black carbon composite structure. Today's mission follows just 5 weeks after Electron's last launch, the R3-D2 mission for DARPA. From day one, frequent and reliable launch has been the goal here at Rocket Lab, and well, now it's our reality. So let's take a look back at that mission.
5, 4, 3, 2.
As you can see, we had a beautiful liftoff on our last mission. Electron safely carried the payload to a precise orbit and continued our heritage of mission success. It was our 5th Electron launch and took our total count of satellites deployed up to 25. We're looking forward to making that number 28 with tonight's launch.
Avionics, flight on mission code.
Flight avionics.
Please disable HVBH and fans and confirm.
HVB heaters and fans are disabled.
GC retract fairing umbilical.
GC flight on mission code. Please send pre-valve open command and confirm. And open the HVBH isolation contactor.
Proceeding with clamp open.
VMS, this is flight on mission code.
Go ahead.
Please confirm all separation events are armed.
Extracting
Confirmed.
strong back.
RF flight on mission code.
Flight RF.
Please confirm the S-band has been switched to high power for flight.
S-band is in high power for flight.
And avionics flight on mission code.
Go flight.
Confirm the stage 2 battery hot swap is ready.
Stand by.
AFTS RCO mission cord.
Go for AFTS.
Arm AFTS and confirm logic is enabled.
Flight stage 2 hot swap
AFTS
ready.
is armed and logic has been enabled.
And avionics, please confirm the hot swap is from stage 2 HVB2 to stage 2 HVB3.
Confirm stage 2 HVB2 to HVB3.
And confirm stage 2 HVB1 and 2 are enabled, HVB3 is disabled.
Confirm stage 2 HVB1 and 2 enabled, HVB3 disabled.
And confirm all stage 1 HVBATs are enabled.
Confirm stage 1 HVBATs are enabled.
Stage 2, confirm stage 2 engine is ready.
Stage 2 engine is ready.
Confirm igniter pressures are within bounds.
Igniter pressures are within bounds.
Confirm carry catalyst preheat is disabled.
Preheat is disabled.
And confirm lock set point to 365 kPa and Kero to 205 kPa.
Confirmed locks at 365, Karo at 205.
Stage 1, confirm all stage 1 engines are ready.
All stage 1 engines are ready.
Confirm range igniter pressures are within bounds.
Range igniter pressures are within bounds.
And confirm stage 1 lock set point is 400 kPa and Kero is 225 kPa.
Confirm 400 kPa for locks and 225 kPa for Kero.
Aboard Electron today, we have 3 experimental spacecraft which will demonstrate advanced new technologies for the U.S. Air Force and for the U.S. Army. This mission was made possible by the DoD Space Test Program and the Defense Innovation Unit. The payloads range in size from a tissue box to a small refrigerator. The total payload mass on this mission is around 180 kilograms, making it Electron's heaviest launch to date. While not as heavy as traditional geostationary satellites, these payloads are highly sophisticated and aim to test a wide range of technology developments, including synthetic aperture radar, avionics miniaturization, space situational awareness, and much more. To learn more about today's mission, let's hear from the Space Test Program.
The Space and Missile Systems Center's upcoming launch, STP-27RD, is the result of an innovative partnership between the DoD Space Test Program, the Defense Innovation Unit, and Rocket Lab USA. This mission is part of the Rapid Agile Launch Initiative, a program designed by the Space Test Program to drive accelerated space access for the Department of Defense. Our goal with this mission is to leverage the growing small launch industry to put satellites in orbit faster and in a more cost-efficient manner. Rocket Lab's Electron rocket provides the perfect chance for the Space Test Program to work with this innovative launch company while delivering state-of-the-art DoD research and development satellites to space. The DoD Space Test Program helps accelerate game-changing new space technologies. This includes spacecraft and the launch vehicles that get them to orbit. Our launch with Rocket Lab will deliver 3 unique satellites to low Earth orbit that will advance space technology for the DoD. These satellites were developed by York Space Systems, the Air Force Research Laboratory, the U.S. Air Force Academy, and the United States Army's Space and Missile Defense Command. The Space and Missile Systems Center is moving faster than ever to deliver innovative, new space technology to orbit and lower the barriers to access to space. We are thrilled about today's launch. This mission will put exciting, new technology demonstrations into orbit and at a fraction of the cost of previous DoD launches. This launch will pave the way for creative new capabilities that enable the U.S. Air Force and the Department of Defense to outpace any space threat.
And we are so excited to be launching these payloads today. Thank you to the Space Test Program and DIU and to all the other teams behind today's mission. Now, as you heard, this mission is called STP-27RD. However, here at Rocket Lab, we also like to give each Electron rocket its own name. We like to get creative with these names, and we've dubbed this one ThatsAFunnyLookingCactus. The name came about because the Space Test Program is based in New Mexico, and if you've been there before, you know there's a lot of cacti around. We pictured what it would be like to see Electron in that setting, and what do you know? It's a funny-looking cactus.
It's RCO on mission cord. Range is green. Auto sequence armed.
Copy.
If you've been following Rocket Lab's activities, you might have seen we recently announced the evolution of the kick stage to Photon, our in-house designed and built small satellite platform or spacecraft bus. As the global leader in small satellite launch, Rocket Lab has made dedicated, frequent, and reliable access to space a reality for small satellites. With Photon, we've taken our mission services even further. Rocket Lab is now an integrated spacecraft build and launch service. So rather than building their own hardware, small satellite operators can simply come to us with their payload and idea, and we'll take care of building the satellite and also launching it. This means our customers can get to orbit faster and start generating revenue quickly by providing real space capability in just a few short months, rather than the traditional years it takes to get to orbit. Photon is an advanced and planned evolution of the kick stage. It operates a high-powered iteration of the flight-proven 3D-printed Curie propulsion system. It can support missions in low Earth orbit with up to a 5-year lifespan. The first Photon customers are launching early next year, and we're thrilled to be streamlining access to space for them. We're approaching T-minus 3 minutes, so let's leave it with Mission Control to follow the remainder of the countdown.
And Flo, this is flight on mission core. Please disable power package vac and confirm. To all operator, vehicle is ready. VMS is flight on mission core.
Go ahead.
You are go for auto sequence start at T-minus 2 minutes.
Auto sequence is locked.
Avionics, this is flight on mission core.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
Confirm vehicles on internal power.
RCO, flight on mission core.
It's RCO, go ahead.
Confirm ground power has been disabled on all 3 stages.
All stage powers down.
And to all operators, vehicle is on internal power.
Pressing locks.
PLS, flight on mission core.
Go ahead.
Please disable anti-geysering and confirm.
Pressing Kero.
Confirmed disabled.
Stage 1, confirm stage 1 is pressed.
Stage 1 pressed.
Stage 2, confirm stage 2 is pressed.
Stage 2 is pressed.
AV battery checks.
High flow engine purge active.
Commanding deluge on.
Deluge on.
Readying GNC systems. Rereading engines.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
First motion.
Stage 1 propulsion is nominal.
As you just saw, we've had successful liftoff of Rocket Lab's STP-27RD mission on ThatsAFunnyLookingCactus. The next major milestone we're coming up to is Max Q, or Maximum Aerodynamic Pressure.
Guidance is nominal.
This is where the forces on the vehicle are at their greatest during flight. So let's listen in.
Coming up on max Q. Max Q.
And there you have it. Electron has passed through Max Q, or Maximum Aerodynamic Pressure.
Stage 1 propulsion is nominal.
Coming up
I have a
soon,
suggestion.
Electron will go through a series of key mission milestones in relatively quick succession. Starting with main engine cutoff, or MECO, the 9 Rutherford engines on Electron's first stage will shut down in
30
preparation
seconds
for
remaining.
Stage 2 separation. Following this separation, we'll see ignition of the vacuum-optimized Rutherford engine on Electron's second stage.
Speed is 2 kilometers per second. Entering burnout detect mode. Five seconds remaining.
Stage 1 MECO.
Stage separation succeeded.
Stage 2 engine started.
As you can see, we have had MECO, or main engine cutoff. Electron's first and second stages have separated from each other, and the vacuum-optimized Rutherford engine on Electron's second stage will continue onto orbit. Very soon, we will see the fairing jettison and fall away from the vehicle. The fairing protects the payloads during ascent, but it isn't needed once we ascend to the thinner parts of the atmosphere.
Fairing separate.
And there it goes. Electron's fairing has been jettisoned to make way for payload deployment approximately 50 minutes from now. With the fairing gone, Electron continues towards orbit. Everything is looking great so far.
Guidance remains nominal.
This is Mission Control Auckland. Electron is performing as expected, and we're continuing on a nominal trajectory. Go Electron!
Stage 2 propulsion is nominal.
If you're just joining us, we've had successful launch of the STP-27RD mission aboard Electron. We've had stage separation, and Electron is continuing onto orbit. Mission Control Auckland checking in with you live during Electron's launch of the STP-27RD mission. As you can see, Stage 2 is continuing on its journey to orbit. Our next major milestone will be the battery hot swap. If you've watched our previous launches, you'll be familiar with this process, but if you're just joining us for the first time, here's what happens. Electron's Rutherford engines use electric pumps powered by lithium polymer batteries, but once these batteries are depleted, they're just dead weight. To overcome this, we perform a hot swap where we switch over power from the depleted batteries to a fully charged one, providing a more efficient ride to orbit. So look out for the battery jettison shortly.
Vehicles to the safe gate.
AFTS is safe.
HV battery hot swap. HV battery eject.
Stage 2 propulsion nominal.
As you can see, we've had successful hot swap and jettison of the depleted batteries. Stage 2 propulsion is nominal and our trajectory is looking good.
One 100 seconds remaining. Speed is 5.5 kilometers per second. Altitude is 198 kilometers.
Just a bit of a recap for the launch of the STP-27RD mission on Electron. We've had successful ignition, Stage 1 burn, and stage separation, and we're now following Stage 2 as it continues onto orbit transporting 3 satellites for the space test program.
Detect mode.
This burn will continue until around T plus 9 minutes, and then our kick stage will separate. So we've got about 1 minute left before Stage 2 engine shutdown.
Thirty seconds remaining. Ten seconds remaining.
Engine shut down.
Transfer orbit looks good.
Confirm stage 3 separation.
And with that call, we can confirm that the kick stage has separated from Electron's second stage. As we mentioned earlier, we won't be receiving video of today's payload's deployment, so we've prepared a short video illustrating this process. At approximately T plus 54 minutes, the 3 satellites on today's mission will be deployed to precise, predefined orbits in quick succession. So stay tuned to our social media channels for confirmation of this payload deployment. So with that, we're going to end today's webcast. A huge thanks to the U.S. Air Force, their space test program, and our mission partners for choosing to launch on Electron. Thank you also to the FAA and the New Zealand Space Agency for licensing this launch. The entire Rocket Lab team would like to thank you for joining us for our 6th Electron launch, and we look forward to seeing you guys again soon. This is Rocket Lab Mission Control signing off.